Okay, so if you design electronics, you know this feeling all too well. You've worked for months, your device seems perfect, and then, boom, it fails the EMC compliance test. It's frustrating, it's expensive, but the very first step to fixing it is actually surprisingly simple. And that's exactly what we're going to break down right now.
So picture this. You're there, your device is sitting in the test lab, and you get the results. Fail. Your heart just sinks, right? Where do you even begin? It's so easy to panic, but really the path forward is super methodical, and it all kicks off with one single crucial question. And that question is, are we dealing with radiated EMI or conducted EMI? You gotta know, these two failure modes are completely different animals. They're measured differently, they happen for totally different reasons, and most importantly, they are fixed in completely different ways. Getting this first diagnostic step right, well, it's everything.
And this breaks it down perfectly. Think of radiated EMI as invisible noise that's literally escaping your device and traveling through the air, kind of like a rogue radio broadcast. Conducted EMI, on the other hand, is noise that hitches a ride directly on your power and signal cables. So, in short, one flies through the air, the other rides the wire. Let's take a closer look at the one that flies.
First up, radiated EMI. This is the energy that escapes your device and just propagates right through the open air. To put it simply, it's unwanted electromagnetic energy coming from your device or its cables and just, radiating outwards. This is the exact kind of interference that can mess with other electronics nearby without any physical connection at all.
So how in the world do you catch this invisible energy? Well, you put the device into what's called an anechoic chamber. It's a special room that's totally shielded from any outside radio noise, creating this super silent environment. And inside, a big calibrated antenna listens for any energy your device is emitting. And a spectrum analyzer shows you exactly which frequencies are the problem.
And this right here, this visualizes a huge clue about radiated emissions. They are almost always a high-frequency problem. I mean, we're talking about noise way up in the gigahertz range, so high that the energy just easily escapes and acts exactly like a radio wave.
So, if your device fails a radiated test, these are your usual suspects. It could be a poor layout on your circuit board. Maybe some unfiltered clock harmonics are getting out. Or, and this is a big one, an unshielded cable is basically acting like a giant antenna, broadcasting noise. This checklist? This is your starting point for the whole investigation.
Okay, now let's flip the coin and look at the other side. Conducted EMI. This is the noise that doesn't fly through the air, but travels directly along the wires themselves.
Conducted EMI is basically electrical noise that contaminates your power and signal lines. Instead of flying off into the air, it travels straight down the wires, and it can pollute the main power grid or interfere with other devices that are connected to that same network.
The test setup here is also completely different. Yeah, it's done in a shielded room to isolate everything, but the key piece of equipment is a LISN. That's a line impedance stabilization network. The easiest way to think of it is as a special adapter that sits between your device and the wall outlet. It lets all the clean power come in, but it diverts any noise trying to get out of your device so it can be measured.
Now have a look at these frequencies. Compared to what we just saw, conducted EMI is a much lower frequency issue, right? We're typically measuring in kilohertz or megahertz, not gigahertz. This visual contrast between the two charts is a fundamental clue in your diagnosis.
And of course, the root causes are different too. Here we're often looking at things like noisy switching power supplies, maybe a missing or just inadequate input filter, poor grounding or common mode noise hitching a ride where it shouldn't. It's all about how that power is managed and contained inside the system.
So, we've seen they're tested differently, they're caused by different issues, and this brings us to the most important part of all, why this diagnosis is so incredibly critical. The whole point is this. You cannot solve a radiated problem with a conducted solution, or vice versa. It just won't work. They are different problems that demand completely different fixes. Trying to slap a filter on to fix a shielding issue is just a massive waste of time and money.
And this slide really summarizes the two different toolkits you're going to need. For radiated failures, you're working with physical solutions, things like metal shields, better circuit board layouts, cable management. But for conducted failures, you're working with electrical solutions, input filters, grounding schemes, power supply design. See? Two totally distinct paths.
Ultimately, knowing whether your problem is flying through the air or traveling down a wire is the key. A correct initial diagnosis is the absolute fastest path from a failed test to a compliant product. It saves you from chasing ghosts and gets you to the right solution right away.
So, with everything we've just covered, the path forward should be so much clearer now. The next time you're faced with that dreaded test failure report, you'll know exactly where to start. Your first and most powerful question is going to be, is it radiated or is it conducted?